Hey guys, what's up? I'm Soumyadeep again back with a new tutorial video. So last video you saw about what? You saw about complementary shear. So I think you will watch what is the complementary shear. But one thing I forgot to tell you, that the classification of the stress. So if you're not watching my last video, so definitely there will be the I button. So you watch this video, complementary shear. So today's topic is what? Types of stress. So today's topic is types of stress. So as I mentioned, stress is a tensor quantity so that this is very important. Stress is acting in which plane? So let me show you. This is a block. This is a block, okay? So if I am telling you this is x direction, this is y direction, this is z direction, so that if force is acting on x direction, so what is stress? Stress is internal resistance force per unit area. So I assume that in this block the area should be A. So if this is the internal resistance force per unit area, should be stress. So my question is that this thing, they are both same stress or different kind of stress. So as stress is a tensor quantity, so it is dependent on which plane this is acting. So let me show you one thing. What is the angle between this angle, this 90 degree? This is the 0 degree or 180 degree. Same thing, 0 degree or 180 degree. So this stress is termed as normal stress. Why normal stress? Which angle? 90 degree. 90 means normal. Normal to which? Normal to the plane. So this internal resistance force which is normal to the plane of this cube, this is called normal stress. And this is which? 0 or 180. So this force is basically parallel to this area. So this is called shear. So now it's time to the universal notation. So universal notation, normal stress is sigma and shear stress equal to tau. Okay. So this is the types of stress in very basic. Later you know there is a bending stress, direct stress, indirect stress, but in a very basic there is two types of stress. One is normal stress, one is shear stress. So normal stress is kind of stress which is acting with a plane with 90 degree. So this side, this side, this side, this side. And what is shear stress? The shear stress is another stress which is acting with parallel to the area or 0 degree or 180 degree between force between area. So now let me show you another thing. So in this video, So till now we know there is two type of stress. One is normal stress and one is shear stress. Well, so the two stress has some pattern, but name is too different. So it is very helpful if you write here simultaneously. So this is very easy for understanding. So universal notation, this is sigma, this is tau. You can say this is the notation. Unit, both are same, Newton per mm square, Newton per mm square. Well, so and diagram, suppose this is a plane, this force is acting this side. So in this area the normal stress is generated. And what is this diagram? So suppose this is force is acting on this plane. So what is happening? So this is typically shear stress. So here deformation happening. So we know that rate of change of the deformation to the original is called strain. So what is happening? There is a length L and change del L. So here strain due to normal stress is called normal strain, that is generally known as epsilon is del L by L. So same thing is happening here. So this is the angle theta. So here shear strain. What is shear strain? For shear stress, then happening the strain. This strain is called shear strain, which is called theta equal to. Suppose this is the x, this is the L. So x by L. Well, so this is normal strain, this is shear strain, and there is another constant which is a constant of normal strain, which is normal stress strain, and which is considered in shear stress shear strain. One is E and one is G. This called Young's modulus, and one is this is called modulus of rigidity. So these two terms is discussed in some later. So till now this is all about. So if we conclude the video, so normal stress is the stress which is acting the perpendicular with the plane. Shear stress which is acting on the parallel to the plane. Number 2, this is called sigma. Okay, let me write here. This is tau, T-A-U, tau. Okay, tau. So this is normal notation sigma, this is tau. both unit are same. Unit Newton per millimeter square, Newton per millimeter square. Both quantity same. Tensor rank 2. Okay, let me write here. Tensor rank 2. Tensor rank 2. This is the diagram. Axial force acting on this plane. This is a small deformation. There, the force acting parallel to the plane. There is a deformation. Shear stress generating theta x by L. And there is a constant term coming which I will discuss in later. So this is G, modulus of rigidity. This is normal strain, epsilon del L by L. There is also a constant which is I am discussing in the next video. This is Young's modulus. So अभी ये टॉपिक मतलब ये वीडियो यहीं तक, फिर मिलेंगे कोई नेक्स्ट दूसरे वीडियो के साथ. Hopefully you enjoying the video. If you like the video, so press the subscribe button, and for notification purpose, so press the bell icon. Goodbye, bye bye, take care. If any kind of doubt, do comment in comment section. Bye.